Good morning. Today I am going to explain about simple stresses and strains, which is the initial topics of the subject strength of materials. So, as you know, strength of materials is most important most important subject both in mechanical and civil engineering departments. So, this is one of the core subjects for both the branches. So let us have a simple introduction towards strength of material. Strength of materials deals with the behavior of bodies under external loads. It's nothing but strength of materials is a subject which briefly explains and gives the mathematical relations of how a body is undergoing different kinds of changes uh, when it is laid by certain loads. So in this you can learn like how the body is going to change its behavior. So whether it is going to break suddenly or whether it is going to provide elastic nature, whether it is going to show its elastic nature, at what point it is going to at what kind of stress it is going to show its yield or ultimate breaking. All those can be found, all those theories can be understood in this strength of material. And this strength of materials basically depend upon all the properties of that particular material which we are using, like all its mechanical properties, whether it can be ductility or malleability or strength or hardness, brittleness, etc. And also type of loading which we are adding on, maybe like point or a UDL, whatever. And one more factor is temperature. It means as the temperature increases, certainly the solid body it starts slightly converting into uh, liquid in nature. So whenever it is losing its stiffness or hardness, and it will start showing its ductile properties. So all type of loading, internal factors, temperature, all those matters for a strength of materials. Next. So first initially we are going to discuss about the loads. Loads are nothing but forces. The load which is laid upon the member is nothing but the force acting on that particular member. So there are various types of forces. So they are categorized or they based on certain uh, criteria. The first one is according to the manner. So according to the manner you have point or concentrated load, and the second one is distributed load. So point load is nothing but, you can see in the name itself defines that the load which is acting on a point. Similarly distributed means it might be distributed around certain area or over a certain length. Next is according to the nature of action. If it is acting static, dynamic, fluctuating, whether it is acting constantly or it is suddenly falling for a few seconds or for part of a second, or it is fluctuating. It means it is increasing or decreasing with respect to time. Next one is according to the effect produced. So according to the effect produced, you have three types. One is axial, shear, and bending. In axial, again it is categorized to tensile and compressive. So first, point load. So the load acting at a point is called as point load. So you can simply say that if the load is acting at a point on the body, it is called as point load. You can take various types of examples. Something like the load transferred by the truck on a rail, on truck wheel on the rail. So it is a point load where the load is acting only where the truck is touching. And this point load is generally distributed only on a certain small area on which the load is present. The point, the name itself tells. So it is expressed in, or it is measured in newtons. Next, distributed load. The load which is acting over an area or along certain length is called as distributed load. So it is expressed in newtons per meter if the load is acting along a length. And it is expressed as newton per meter square if the load is acting over a area. And generally this can be further classified as uh, if it is constant over a region, it is uniformly distributed load, and if it is changing from point to point, it is called as uniformly varying load. Next, static load. So the static, it means it is constant. So the load which is acting with the same value. It means, say if I'm applying certain 10 newtons of force on certain point, so that will be acting just like that only. It is not going to change. It is called as static load. The loads which are gradually applied up to a long period of time. So if you are placing anything on a bench, so that is a static load. So if a person is sitting on a bench, it means he might be sitting till the end of the period. So it is an example of static load. Next, or else you can say that a load hanging off with a chain without raising or lowering. The example is hook we can take now. So that is also static load. Next, dynamic load. So dynamic load are nothing but the load which are falling suddenly. Means the load can be, uh, it is simply referring as the impact or sudden impact or falling from certain height. So during which it will act on the body for a small fraction of a second, but the effect of the loading will be very high. The example is the hammer dropped on a pile. So the hammer may drop for a few seconds, but the pile gets broke. So example is hammer dropped on a pile. So next one is the fluctuating or shear or cyclic load is also there. So it is nothing but the load is continuously varies. It means it changes from point to point. The example is the load acting on a connecting rod of an engine. So the load acting on a connecting rod of an engine. So what happens when it is in the to and fro position? It will be varying. It will be changing from point to point. Next, axial loads. So these axial loads are nothing but the loads which are acting along the longitudinal axis of the structural unit. So simply we can say that the loads which are acting along the axis of the member, parallel to the axis of the member. So in this, if the forces are dragging away from the body, it is called as tensile load. So in this, what happens when it is dragging away from the body, the length of the body increases due to the effect of this tensile load, and its cross-sectional area decreases. And similarly, if the force is acting or it is moving towards the center line of the body, means something like if you are pressing a rectangular bar from both sides, what happens? the body will be decreasing in its length and its cross sectional area increases. So that is compressive load. So in the same way, if you are pulling the two opposite ends of the rectangular bar, what happens? Its length increases and the cross sectional area of that body decreases. So those are two, tensile load and compressive load. If you are pressing towards the center, it is compressive load. If you are pulling it away from the center, it is tensile load. Shear load. So the shear load, it is nothing but, so it is the tangential load which is making a part to cut or slide. Say if two bodies are sliding over each other. So what happens when a body is sliding over another body? So there occurs a tangential forces over the area which is in contact. Say if one body is completely rough and the other body is smooth, what happens? So due to the rough nature of one body, when the smooth body uh, roughs the surface, the part or the material of the edges might be removed off due to this tangential force. So this is nothing but shear force or shear load. So when two bodies or when a structural member is rubbing with the surface or with a part to be cut with the aid which is used to cut. So what happens? The sliding of the surface occurs and this may lead to the removal of the material. So generally we can say it as wearing of the material. It is shear load. Bending load. So this bending load is generally acting at the ends of the body, which will make the body to bend. So if it is a straight one, so it might be bending to a U or a reverse U. That is bending load, which will make the body to bend. It's nothing but bending load. And next, so thereafter, so those are all the types of loads. Now next comes stress. Stress is nothing but something like pressure built up due to the load. So what happens when the load is acting on certain body, say W. So the body, what it does is it will try to resist that load from breaking down. If the load of W is 41, let's say. So this will uh, give the internal resistance of W to make itself stable and not to be affected by the load actually imposed on it. So this offering resistance is nothing but stress. So this stress, you will have various types of stresses in this again. If it goes on, you may have ultimate stress, working stress, all those. Ultimate stress is nothing but at a time where it cannot withstand that and it will break up. And the part may not give the enough resistance to withstand that load. So stress is nothing but the resistance offered by a body per unit area of cross section. And the stress is measured in terms of Newton per meter square. And it can also be defined as force per unit area. So stress is equal to the mathematical equation is stress is load by area of cross section. Load is nothing but the weight or the force that is acting on the member or on the body, and area of cross section is its area, which is nothing but, if it is a circular cross section, we will consider as pi by 4 d square. If it is a rectangular cross section, you will take L into B. So it is depending on the cross sectional geometry of the member which we are taking. So next again, the stresses are three types. So tensile stress, compressive stress, and shear stress. So tensile stress, nothing but, so as we already know that tensile load is nothing but, so along the axis, if the load is making the body to move away from it, means if both ends are pulled away, is nothing but tensile load. So when this load is acting on the body, what happens? The body, the load will, the length will increase. I mean, the length is, it is like something dragged or extended. So this type of thing is called as tensile stress. So here a small mistake has occurred. It is called as tensile stress, but I mistakenly had made it tensile load. So kindly forward it. So in this tensile stress, what happens? The increase in the length occurs, and due to the effect of this stress, the increase in the length occurs, and again the decrease in the cross-sectional area occurs. Again the same formula. Tensile stress is nothing but tensile load by area of cross-section. Compressive stress. So when a load tends to push the particles of the body, causing shorten in the direction of the load. So when the load is acting again axially, and if the load is equally upon both the opposite sides and it is pushing towards downwards, towards the axis, central axis, what happens? The length decreases. So due to the decrease in the length, what happens? Its cross-sectional area increases. So this effect is nothing but again compressive stress. So in this again, compressive stress is nothing but compressive load by area of cross-section. So prior to compressive stress, so after acting of this compressive stress, its cross-sectional area increases. Next, shear stress. So shear stress is nothing but again. So we know that shear force is nothing but the tangential force which is acting. Simple example is something like rubbing of the two material. So the tangential load which is making the body to cut or to slide the bar is nothing but shear load. So the corresponding stress which is induced is nothing but shear stress. So when it is rubbing over it, so automatically the resistance is offered by the rubbing side of the member. So that resistance is nothing but stress, shear stress. So for shear stress you can calculate simply as shear load by area of cross section. The same formula, load by area for everything. Next, strain. So strain is nothing but deformation due to external loading. As you know, before loading, say if you take a tensile load, so before loading it might be a length of L. So after tensile loading, what happens? As you know, the length increases. Say some L plus delta L. So now this strain is nothing but this change in the length to the original length. So change in the length means initially, so now finally it is L plus delta L, and the original length was L. So L plus delta L minus L by original length is again L. So L and minus L cancels, and at the end we'll have delta L by L. It is nothing but the difference in the lengths before loading and after loading by the original length. So strain is simply as deformation due to external loading, or it is nothing but change in the length per unit length. Strain is equal to change in length by original length, and this will not have any units because in the numerator as well as at the denominator you will have only lengths. So both the units are same, so you will not have any kind of uh, units for this. So thank you. This was the simple stresses and strains.